I'm very happy about our next presenter to introduce Professor Dr. Tjark Siefkes. He is Director of the Institute for Vehicle Concepts at the German Aerospace Center, short DLR, here in Stuttgart. In his life from 2000 to 2012, he was Vice President Research, Product Management and Competence Center at Bombardier Transportation. Then a few years head of System Engineering and Light Sources SAML, from 2019 he joined the German Aerospace Center, and you will present us a project or a project universe called UShift, meeting the requirements of future urban road traffic. We are happy to have you here. Professor Siefkes, the floor is yours.
Thank you, Wolfgang. A warm welcome from my side to the audience on the screens. UShift, meeting the requirements of future urban road traffic. The title, as it says, we first have to dig into the requirements. Where do they come from? They come from, of course, protecting our climate. Green Deal, for example, is a buzzword, a catchword nowadays here. But on the other hand, it's also about ensuring mobility for the future. And both don't necessarily go hand in hand, even they are contradictory at first. So what we have to do is, what we are aiming for is to manage the transformation of transport and ensure that these gears really go twos and twos. How do we do this in the German Aerospace Center? We are roughly 10,000 employees, not only, as the title says, working on space and aeronautics, but we're also focusing on ground traffic, on energy, on digitalization, and as well as security. So we can dig into employees which are working in technical areas, but also employees which are focusing on other domains like psychology, medicine, etc. This enables us to think in systems. I only are going to look into two questions here. On the transport system side, for example, who will be driving in the future? That's what we are going to address today. But on the psychology side, of course, also is a big question. Do I need to know what the vehicle knows? And there's a big branch of questions which needs to be taken into account when we want to do the transfer of transportation into the future in a good way. Looking at the Green Deal, the European Green Deal, I brought this graph for you. On the y-axis, we are looking at decarbonization of transport. The Green Deal says, please do decarbonization by 90% compared to the reference of 1995 for the whole transport area. Which means that, first of all, we have to make the primary energy completely out of wind, sun and water energy, but also the industry production needs to be environmental friendly as well as the direct emissions. And as you can see, it's a tough target because when we move from summer to winter in Central Europe, then we need to store a big volume of energy to have regenerative energy also available in winter time when it's dark, also at night time when there's low wind times. So it's a big risk to achieve that goal, and there's a big variety and a big chance that we're going to miss this goal. So forget about this y-axis. I brought you another solution. This is put on the x-axis. What if we only are going to use 10% of the energy we used for transport in 1995, then in 2050? So energy reduction by 90%, and bingo, we are there where we wanted to be. And of course, obviously, that's also not going to work out for technical reasons. So the only chance is to combine both, and this is the solid line, the solid yellow line you can see in here, which gives us a target corridor for 2050. So the energy reduction on the technical side, feasible is round about between 40–45% at maximum. This is what we can achieve. But if the decarbonization rate really goes below the 90% target, then this target corridor becomes easily very small. Same goes for the EU plan for 2030 for the fleet emissions of the manufacturers to be targeted at around about 37%. Also here the target corridor is pretty small. So we have to combine both activities, political activity in decarbonization and technical activities in energy reduction on large scale. There must be a handshake between politicians and industries, and this is the only way out of this dilemma we see here. But there's more to it than just decarbonization. We're looking at health, for example, in urban areas. We have the cap issue that providing courier, express and parcel services, which are heavily grown currently, are disturbing inner cities, producing emissions, more and more emissions. So the expected cap rate in Germany in 2022, now with the focus on the pandemic problems, probably are going to be even higher than the originally predicted plus 33%. So what we see is that large amounts of courier and parcel services being operated in inner cities. If you look into other countries like China, for example, we have even higher rates here, around about between 45% and 60% growth rates. That is what we see. So the majors of the cities, like Stuttgart here, they are going to try to eliminate private traffic in urban areas, which creates a problem situation which is multi-layered and highly complex as well. We're not only looking at mobility infarction and the health endeavors, which we just discussed here. We're also looking into technical questions where we see increased competitiveness pressures from Asia put on our automotive industry. So there is high innovation pressure we see here. And of course, fears in society and in politics about what is really going to happen in the future with a high amount of activity on all levels and still quite some low coordination. This is, as I originally said, needs to be changed. We have to go hand in hand in our approach. There are multiple approaches here. What we can do is, of course, entangle freight and passenger transport. If we make freight transport environmental friendly, low noise, etc., electric mobility, then we can put this into the night times and do the passenger transport at daytime. And of course, to face the pressure from Asia, for example, we have to be more efficient here, like a 24/7 operation of the capital-intensive systems we have here, and that is traffic, of course, as well. So the use of digitization is one part, but also we have to create new business models, looking at citizen participation as well to address fears in society. And overall, it's an integrated approach, which leads to a really leapfrog innovation and not just step-by-step enhancements. This is how we created UShift. And we, that is the University of Ulm, together with FKFS, Technical University of Karlsruhe is involved as well, where we look at various areas. So we look at on-demand transport, automotive or mobility as a service as well, but also at the small and medium-sized enterprises. How can we ensure that they develop for the future to come? And this is where we help them as well. The whole thing, UShift, is invented in Baden-Württemberg. We are proud of this, and the SDA, which is our host here, is highly supporting us and driving us into this future. How does it look like now, this UShift, let's call it truck, maybe is the best word. It's a highly modular vehicle, which is modular on the road. So it changes during service between parcel transport, for example, passenger transport, so cargo and passenger transport. And everything what is costly, we put into this drive board, the white vehicle, for 24/7 hours operation and for autonomous transport as well. The cargo capsules, that is where the medium-sized enterprises, companies can dig their teeth into. They're intermodal in size, in shape, they're highly standardized, but also employ individual functionalities as well. Same goes for passenger capsules, for on-demand transport, for edge zone operation, as well in time as in place in urban areas. So in overall, what we can see here for UShift, it really integrates today's vehicle concepts, bringing them into the future with integrating plant engineering concepts, that is this, for example, 24/7 operation, and making that leapfrog innovation possible. It is highly modular, not only in operation on the road, but also in its layout. We have foreseen currently 3 sizes, large, medium, and small. The medium size, what is named in German Kleinbus, that is a 3.5 ton UShift, which operates 10 to 12 people on the one hand, or has a payload a little bit larger than 1 ton for cargo transport. So UShift is scalable in size as well as in business services. This is one thing. The other thing is that it is not easy to operate autonomous vehicles in urban cities. This is what we are addressing in the whole conference today here. With UShift, there is multiple challenge which comes upon us. It needs to be safe and secure, of course, operating in inner cities. But what we also need, we do on-demand transport, when we do on-demand cargo transport as well. We need to have a traffic control center. Fleet management goes with it. And of course, to minimize energy usage, to achieve a Green Deal, we have to have a strategic routing and deployment planning. So it cries for a kind of transport center in the back end, which has to run edge computing, of course. We need to see how much energy we put on the UShift, as well as how much energy do we put into infrastructure. We need to foresee a good mix here, also to minimize the computing energy in overall. The road capturing units, of course, have to go hand in hand with the deployment questions. Probably we are going to see sensors at big crossings, at highly secure areas in the inner cities. So sensor units also have to go hand in hand, of course, with the general data protection regulation. That is where I say it's more than just technology, it's psychology, it's also about then legal questions we are addressing here, giving us the big flower of UShift to come in the future. So it's all about managed automated driving, which we are tackling in the years to come. What did we do? We built a first prototype of this UShift vehicle. Here you can see the white drive board, we call it. That is where we have the autonomous part in it. The batteries are placed in here, the electric motors gearbox, and it is tailored to pick up different settings, like what you can see on the right side. The passenger module, the passenger capsule. Also on the left side, on the next picture, you see then the cargo capsule. In this case, we produce example-wise cargo capsule which is refrigerated, which then also extends the discussion about energy distribution, connectivity on the whole setting of the car, of the autonomous car, and the capsules we put on them. So overall, it's quite some time to go to make this really finally operation at SAA level 5. We have demonstrated it on Stuttgart Fairgrounds. It's an enclosed environment where we can do the operation, but until certification and operation in mixed traffic on the roads, it's some time to come. I'm happy, I'm looking forward to this. I'm happy to run this project as well, together with the mentioned colleagues from the other research institutions. And with this, I would like to say thank you again for listening, for being here with us on the SDA Digital Hannover Fair. Thank you.
Thank you very much to Professor Dr. Tjark Siefkes from the German Aerospace Center. I have a really interesting question, but I would suggest looking to the time that we come up to this in the panel discussion. But yeah, just a very short question. I mean, UShift is a very modular and flexible concept, as you pointed out, and you also pointed out that operating autonomous vehicle is not that easy. It's quite difficult. So actually, the possibilities are really broad. So what do you think in future? Will we have a mixture between the operators transporting persons and goods, or will it be different? Will there come a completely new operator, or will it be the operators we know from today, but with new knowledges?
It will be a mixture. So it's not a black and white here. What you're going to see is that there are operators like we have them today running public transport. They will use this, they will put it into a mixed operation. There had been some examples for trams, where trams in nighttime deliver cargo. In Frankfurt, for example, in Berlin, we saw this. So you can do this on the road as well. But others, as current logistic companies, cargo device companies, they're going to use one part of UShift and then hand over the drive board to other companies who only do passenger transport. So you see then there will be a kind of a leasing, a new type of leasing for the costly drive board, and then the cheap and simple settings for the cargo capsules, for the passenger capsules, that will be then owned and managed by different companies as well.
I think we can go a little bit more in detail in the panel discussion afterwards. So thank you very much for now, for your interesting presentation. And I'm looking forward to discuss with you some more aspects in a few minutes.